what's up, guys?
Hey!
Hey Josh, how you doing?
Dude, not good, honestly. My phone, no matter what I do, dies all the time. I charge it, and like 5 seconds later, it just dies. And I don't know what's going on.
Oof. Sounds like you're overcharging your phone. You should get up in the middle of the night and unplug it so that it doesn't keep doing that.
Yeah, the current can heat up the phone and cause damage to the battery.
Y'all, we should make a device that unplugs the phone when it hits 100%, and then you don't have to worry about the battery being damaged.
That's an idea I can get behind.
I like it.
Let's get started.
What if we did something like this? The user will plug their phone in and put it on the base. Then they'll input how much battery percentage the phone has, and this arm will disconnect the charger after a given amount of time.
Instead of inputting the battery percentage, we could use a current sensing charging cable to determine when the phone is fully charged.
I love that idea, Emily, but instead, what if we do this? Okay, so in this new design, we will use an Arduino that's connected to a motor to unplug the phone. The Arduino will sit on a base that will have a wall coming off of it. The wall will have 2 phalanges that extrude from it. The phone will sit on both of these phalanges and will be connected to a charging cable. The charging cable will be connected to links 1 and links 2, and these links will be connected to the motor that will rotate and unplug the phone, like so.
That's good, but I think we should box everything in. That way it's a little bit more sturdy and aesthetically pleasing, and then we can add a button on top for if you need to unplug your phone early.
So, after deciding on a design, we set out to create our device. The first step was to decide on the materials and parts needed to construct it. To design the physical pieces, we used SolidWorks. The program allowed us to model each piece and then 3D print them. We decided on this method because it was cheaper and allowed us to better customize our parts. The pieces that we created were a base, 2 identical sidewalls, a back wall, a front wall with phalanges and a slider slot, a top wall, a coupler, a crank, and a slider. Once these parts were designed, they were 3D printed. We then turned our attention to the electrical components. We decided that for the electrical components, we would use an Arduino Mega as our circuit board, a stepper motor to turn the links, a driver board, a breadboard, a button, a resistor, and DuPont wires. All of these pieces were purchased online. The total cost of the whole device came to $46. To construct the charging station, the 3D printed frame pieces can be snapped together. Then the electronics can be connected and placed within the frame. The breadboard is placed in the slot on the top wall. A button is then connected to it. The crank is then connected to the motor and the slider connected to the crank by a link. The crank and the link are held together by a screw. Ideally, they would be made of the same 3D printed material, but the screw is made of a much stronger material. Finally, the lightning charger can be glued to the slider. When fully constructed, the device should look like this. The purpose of the code is to regulate how the crank slider interacts with the phone. This was done by interfacing a button with the Arduino. Code was then written to tell the Arduino what to do when the button was pressed in different situations.
The portion of code highlighted starts the timer when the button is first pressed. This portion of code runs once the timer has finished. It deactivates the timer and also unplugs the phone. Here, when the button is pressed, it interrupts the timer, so the code deactivates and resets the timer, and also unplugs the phone. The code shown returns the crank slider to its initial position once the button has been pressed another time.
Once the device is constructed and coding is completed, the device will unplug the phone after a certain amount of time. The timer can be changed in the code so that the charging time varies. For the sake of demonstration, it is set for 5 seconds.
Initially, when the phone is placed on the charger, the button is pressed to start the timer. If it is not pressed again, then once the allotted time has passed, the phone is unplugged and the crank slider moves to the fully retracted position. However, if the button is pressed while the timer is running, The timer is then stopped and the crank slider is moved to the fully retracted position. Then, to return the device to its original position, the button must be pressed again. Now the device is ready to charge another phone.
The mechanism implements a crank slider in order to remove the charger from the phone. We use vector closed-loop analysis to determine the positions and velocities of the crank slider mechanism based on the changing values of theta 2. We were able to determine the limiting positions and the stroke of the crank slider. The stroke of the slider is approximately 0.6 inches. The limiting positions occur when theta 2 is at approximately 11 degrees or 202 degrees. We also found the slider's velocity at an arbitrary angle of 20 degrees. At this point, the velocity of the slider is approximately 4 inches per second. At this arbitrary angle, the crank slider has a mechanical advantage of 7.57. Now we will discuss the limitations of our design and possible improvements. The phone is unplugged after a given amount of time, but charging time could vary. It would be ideal to have a current sensor that would notify the device when the phone reached full charge, and then the device would unplug the phone. The type of phone case used will affect if the phone fits on the charging stand. If the phone case is too bulky, it sticks out too far for the charger to fit into the port correctly. Using an adjustable clamp to hold the phone in place would make the device more stable. This clamp would be in place of the current shelf and would also make it possible to adjust where the phone sits on the base and therefore allow for thicker cases. The device only disconnects the phone charger. It does not have the ability to plug the phone in. So the phone must be connected to the charger manually. Using a custom circuit board instead of a pre-made Arduino board would allow for a smaller and more purposeful design. The appearance of the charging station could also be improved. Making the box smaller and sleeker would also make it more convenient. Putting the button inside a casing that would hide the breadboard and attached wires would also be another improvement. Adding a button that is separate from the start button to eject the charger would make it more user-friendly. There are no mechanisms like ours currently on the market. There are phone docks that hold the phone and other electronics while charging, but they do not unplug the phone when it is done charging. There are versions of docks where the charger is a built-in part of the device and others that serve as just an accessory, and you have to supply the charging cable for them. Our device has the charger built into it, and it cannot be interchanged. There are no other accessories for phones, chargers, or docks that can be added in order to unplug the phone when it is done charging.
After careful planning and preparation, we were able to create the phone unplugger. We designed the pieces in SolidWorks, 3D printed them, and ordered electrical components. We then constructed the frame and connected the electrical components. After this, we instructed the device what to do through coding. We then performed an analysis on the crank slider mechanism that unplugged the phone. Finally, we discussed the limitations of our design and compared it to existing models.